Okay, this is naming and formula writing. We're going to start with naming because we've just talked about formula writing when it came to word equations and predicting products for our chemical reactions unit. So I'm going to focus mostly on naming, but I will do a quick review of formula writing as well. When you name things, there are a few things that you need to check and see if you have, if there are cases, okay? First thing you need to check and see is if you have a metal, okay? Remember, metals are to the left of the staircase on the periodic table. If you have a metal, you do not use prefixes. When I say prefixes, I mean things like di, tri, tetra, okay? You do not use prefixes. You would not tell me carbon dioxide, okay? If you have a metal, you have a few extra things that you need to check, okay? Does the metal have multiple oxidation states? If your metal has multiple oxidation states, this is the only time that you use a Roman numeral. This is the only time that you use a Roman numeral. If you take out your reference table and you take a look at manganese. Manganese is number 25. Manganese has 4 options. Manganese can go to +2, +3, +4, and +7. Okay? When you're naming something, you've got to tell me which one it's using. Your Roman numeral is not going to tell me that it's using the 3rd oxidation state. If manganese was using +2, your Roman numeral would be 2. If manganese was using +3, your Roman numeral would be 3. If it was using +4, it would be manganese 4. And if it was using +7, it would be using, you would use Roman numeral 7. Okay? This does not mean there are 7 manganeses. It just means that manganese is +7. Okay? This is the only time a Roman numeral comes into play, is if you have multiple oxidation states. Use it to tell me which one it's using. Additionally, you need to look and see if you have a polyatomic ion. You should be good at recognizing those by now. If you have a polyatomic ion, the name of the ion is on table E. Take a look at table E and figure out what its name is. Remember that the charges, the superscripts, so if you have something like NO3 minus, this is the oxidation state, the minus. It means -1. You might have SO4 2 minus, and the oxidation state of sulfate is -2. Okay, you do use some very common ones. Nitrate and sulfate are probably the most common ones that we use. If you don't meet either of these criteria, when you name something that has a metal in it, all you do is state the name of the metal, and then the name of the nonmetal, but end it in "ide." Okay? So an example here is LiCl. Okay? Lithium is a metal. It's to the left of the staircase. Okay? Lithium only has 1 oxidation state. It only goes to +1. And I only have 2 elements, lithium and chlorine, and therefore I do not have a polyatomic ion. So if I were to name this stuff, it would be lithium chloride. Now let's see how that changes as I run into either of these 2 cases, multiple oxidation states and polyatomic ions. If you just have 2 things, one of them's a metal and the metal only has 1 oxidation state, you just name it as lithium chloride. Okay? However, let's say that metal has multiple oxidation states. So I'm not going to make it lithium anymore. I'm going to change it, and I'll do it in a different color so you can see what I change. Change it to copper, Cu. Now I have CuCl, and I need to know what the name of that is. I still only have 2 elements, so I don't have a polyatomic ion, but I do have multiple oxidation states because copper can come in as +1 or +2. So I know it's copper, so I'm going to write the name of the metal because that's always how you start. And I have to figure out if it's using +1 or +2. We've had a little bit more experience with this. Chlorine, we can just reverse the flip-flop. We know chlorine's -1. It's a 1-to-1 ratio, so this must be copper 1 chloride. Okay? Copper 2 chloride would look a little bit different. Copper 2 chloride would be Cl2. And then this would make this copper 2 chloride. You have 2 chlorines. Each one brings a -1, and therefore copper is going to have a charge of +2. So that would be copper 2 chloride. All right. Last case for now. We have a polyatomic ion. So we can leave it as copper 2. And let's say that we make it copper 2, we'll make it sulfate. We'll change it from Cl to SO4. I see SO4. If you look at this and count the capital letters, I have 1, 2, 3. In order to name anything with 3 capital letters that has a metal or a polyatomic ion in it, you need to go to table E. If I look up table E, I see that this is no longer chloride. This is copper. I'll keep the 2 there. This is copper sulfate. Polyatomic ions do not change their name and they do not let go. That means it's sulfate on one side, it's probably going to be sulfate on the other. Okay? So you just pull the name right from table E. From table E. You do not change it to sulfide. Okay? Sulfide would look like this. That would be copper 2 sulfide. So sulfate means something very different. So when you're looking for a polyatomic ion, we'll do this when we do formula writing, things that end in -ate and -ite are polyatomic ions. Okay. Last case is if you don't have a metal or ion. No metal or ion. If that is the case, you use prefixes. Your prefixes are as follows. 1, 2, 3, 4, 5, 6. I think that's about as high as you'll need to go. 1 is mono. 2 is di. 3 is tri. 4 is tetra. That's the one everyone forgets. 5 is pent. 6 is hex. Okay? So, if you're going to name something such as SF6, S and F, sulfur and fluorine, are both to the right of the staircase. That means neither of these are both non-metals. Neither of these are metals. So I know I need to use prefixes to tell me how many. So these prefixes tell you how many. You don't need to worry about oxidation states. Make sure it still ends in "ide." So this stuff becomes monosulfur. That means I have only 1 sulfur. Hex of fluoride. So there's still an "ide." Don't forget that when you're bonding things, that's how I know it's not fluorine. It's not just the element, but it's fluoride. Okay? This would mean 1 sulfur, 6 fluorines. Okay? Very easy to go the other way. If I tell you if I give you monosulfur hexafluoride, or if I tell you diboron trisilicide, stop thinking about oxidation states. As soon as you see a prefix like this, that indicates how many. It's not a Roman numeral, it's a prefix. So it's going to be, this would be B2SI3. Okay? Your subscripts come directly from the prefix. All right. Additionally, if you're writing formulas like we did for formula writing and for word equations, whenever you write a chemical compound, okay, whenever you write the formula from a written out English word name of a chemical compound, you need to do a flip-flop unless there are prefixes. So this case here is no prefixes. what you need to do is you need to look up the oxidation state for both elements. Remember, if it's a non-metal, if it's the negative one, you take the top one. And if it's a metal, you need to either use the Roman numeral that was given to you or take the only positive it has. Remember, the positive one is written first. So if I'm starting with something like, let's say, calcium bromide. We know it's bonded because it says "ide." We know it's a formula. So I need to write calcium and bromine, and I need to look up the oxidation states. If you have your reference table, do this, okay? Calcium, if you look it up, is +2. Bromine has a couple options, but the top one and the only negative one is -1. Okay? So when you write the formula for this, you take the absolute values of the oxidation states, the top numbers, and you take the 2 and you put it as a subscript for the bromine. Then you take the 1 and you put it as a subscript for the calcium. So this becomes CaBr2. The reason we do that is to make it all neutral. All the positives and negatives cancel out. However, if we changed it up a little bit, if we have cobalt 4 bromide, oh my goodness, we have a Roman numeral. What do? The Roman numeral actually makes your life easier. Okay, I know that you guys tend to hate them, but it actually makes your life easier because what it's telling you is that this cobalt has a charge of +4. No reference table required. Okay? Cobalt has a charge of +4, and I remember that bromine has a charge of -1. So this is COBr. The cobalt is +4. The bromine is -1. The 1 goes here. The 4 goes here. This becomes COBr4. Okay? Remember cases like magnesium oxide. MgO. Mg is +2. Oxide's -2. When you flip-flop this, it becomes Mg2O2. When you flip-flop anything, make sure that you reduce to the lowest term. So reduce, if you can. This would become MgO, and that's your proper formula. Mg2O2 is incorrect. Last thing for naming, for formula writing, excuse me, it's polyatomic ions, okay? Let's say calcium phosphate is very different stuff than calcium phosphide. The difference here is the ide versus the ate. If it's ate or ite or hydroxide, if it ends in ate, ite, or oxide, like with something, so this would be like a hydroxide, okay, you need to use table E. Remember, like I said in the beginning, the oxidation state on table E is just the superscript charge. So we have calcium, which is +2. Phosphate is PO4, and it is 3-, okay? Remember, it's helpful to put polyatomic ions in parentheses whether you need them or not. Calcium phosphide, calcium is still +2. Phosphide means just P, and that's -3. Flip-flop this becomes Ca3P2. That is calcium phosphide. Flip-flop this, it becomes Ca3PO4, and that's calcium phosphate. So please, please, please pay attention to that. Even with polyatomic ions, if you can reduce them, you do. This is a 3-to-2 ratio, which I can't reduce, but if it was 4-to-2, for example, if it was Ca4PO42, I could reduce that down.